Today you are looking at a review video on rational and irrational numbers. By the end of the video, in addition to notes you've already taken, you should be able to identify whether or not a number is rational or irrational. So let's review. Let's start with some vocabulary. If you do not have this already in your notebook, this is a great pausing place so you can get the notes in your notebook. The first vocabulary word I'd like to go over is rational numbers. A rational number is a number that can be written A over B, where A and B are integers. Let's make sure we understand which operation is taking place here between the A and B. A over B, or A divided by B. That bar, that line, represents a fraction, which the operation is division. So rational numbers can be written as a fraction, is what that basically says. The next definition is irrational. Irrational numbers are numbers that cannot be written as a quotient of two integers. So it's saying it can't be written as a fraction. The last vocabulary word is real numbers. Real numbers is just the set of both rational and irrational numbers. So to take the vocabulary, let's look at it in this way. Real numbers are all rational and irrational numbers. So it's here at the top, real numbers. Then you can break down rational numbers into two categories. Integers, numbers that fall on a number line. -2, 2 are integers. And then whole numbers, like 0, like 1,000. These are all rational numbers. Whole numbers are rational, integers are rational. If you notice here, irrational doesn't have any additional categories of numbers. You just have irrational numbers. If you don't have this chart in your notes, again, a great pausing place to document this chart is very important. And I think does a good job of showing the difference between rational and irrational numbers. So let's talk about sometimes where you have numbers that you maybe don't know if it's rational or irrational because it comes in fraction form. Well, keep in mind fractions, for example, 1/2, 1/2. I'm not sure why it's not writing. Oh, here we go. 1/2. That number, that fraction, can be written as a decimal. So when you have decimals, you need to break them down into 3 parts to see where it falls. There are terminating decimals, repeating decimals, non-repeating or non-terminating. So let's talk about terminating. The word terminating means to terminate, to stop, to end. That means the decimal just ends. For example, 0.25. Well, that can be written as 1/4. So here you have a fraction written as a decimal, and it terminates, it stops. Because it terminates, it is a rational number. Repeating decimals also are considered rational numbers. They repeat forever and ever and ever with the line above it or a ... to let you know it continues. For example, 1/3. 1/3 is 0.3 repeating. Because it has a pattern or it repeats, it is a rational number. Lastly, non-repeating or non-terminating means it doesn't repeat, there's no pattern, and it doesn't stop. It continues to go on forever and ever. And because it has this ... and there's no pattern, you don't know which number is next. This type of decimal is irrational. numbers. One main example is pi. Pi is 3.14159 ... We don't know those numbers. Now, if you memorize it, you do, but most people don't. They just know pi, and pi is irrational because it doesn't repeat, there is no pattern, and it doesn't terminate. It continues on forever and always. These examples for fractions and decimals will help you better clarify and classify if the number is irrational or rational. So let's just do some practice to be clear. Tell me whether or not the number is rational or irrational. Let's look at example 1, 144. Well, I'm sure it's an integer. It can be on an integer line, number line. It's a whole number. And we looked back here at our categories. Whole numbers, integers are therefore rational. So I know this is a rational number. What about the square root 36, number 2? I see a square root sign and I may think, oh, it's irrational. However, we know square roots work if they're perfect squares. Is there a number that is multiplied to itself to give me 36? Yes, 6. 6 is a whole number. It's on the number line. It's an integer. Therefore, it is considered a rational number. Well, let's look at the last two. 0.30311 ... Well, I see this is a decimal, and I go back to my 3 types of decimals: terminating, repeating, non-repeating, and non-terminating. Well, I know it has a ... which lets me know it continues to go on forever. But I don't see a pattern. Therefore, it's an irrational number. I don't know what numbers can be after that ... because it doesn't show me. There's no pattern. Well, last one, number 4, 3/5. Not sure what to do, but I do know this is a fraction, and I know fractions can turn into decimals. So I need to solve it. I need to figure out if this can be rational or irrational. So I'm simply going to solve. The denominator, goes on the outside of the house. 5 does not go into 3, so I'm going to put my decimal at 30. Or add a 0, I have the number 30. Can 5 go into 30? Yes, 6 times. 3.030, subtract, I get 0. So 3/5 equal 0.6, which is now a decimal, which means I can go to my rules and look at it. Is it terminating? Does it stop? Well, it does. 0.6, nothing else. Therefore, this is a rational number. I hope this clarifies the difference between rational and irrational. Again, if you don't have this information, you need to put it into your notebook. Thanks for watching.